Hi, it's Eric from EDD Academy, and I'm going to be doing MIT Integration B Problem 18 from the 2019 qualifier exam. So, we got this messy integral, but we can actually use a little trick I like to call the e to the ln x trick. I know, unimaginative, but we can rewrite the integral in a more convenient way. So we can actually do some little algebra manipulation to maybe do a u sub or something. So, rewrite it. Just rewrite it like this, and just for a little bit of clarification, put the parentheses around so you know that all that's inside the ln x function. And then just as a quick note, we know that log x is actually equal to ln x. That's just one of the things about the MIT Integration B, is that when you get into higher level math, the only log function the most common log function is just ln x, so you just write it as log x. And we're going to do a little bit of algebra on the bottom using some e to the ln properties, so just rewriting it right here. So we can actually take this x squared plus 1 exponent and move it to the outside using an ln property. And then since we can't really do anything else, I'm just going to distribute the ln x throughout this entire x squared plus 1. So it becomes e to the x squared ln x plus ln x. And then we can split up this top because we know that e to the x plus e to the x is e to the 2x, or I mean e to the x times e to the x is equal to e to the 2x. So we can rewrite this as e to the x squared ln x e to the ln x. And the e to the ln x cancel, and you get e to the x squared ln x times x. And now we can just substitute this in our original integral like this. 0 to bounds don't change of e to the x squared ln x x to ln x plus 1. And the next step I'm going to do is I'm going to distribute this x into the 2 ln x plus 1. So right down here. So from this point, we can actually do a u sub. After all that work, all that algebra, it's actually a very convenient u sub. So I'm just going to write it down at the bottom here. So we're going to set u is equal to x squared ln x, and then using the product rule, we can rewrite this as du x squared 1 over x plus 2x ln x. And then to best match the form of the original integral, we know that the 1 over x and one of the x's on the x squared cancel, so we can rewrite that as 2x ln x plus x dx, forgot the dx up there. And now we can just do a very easy u sub. So we get the integral, and then let's look at the top first. Well, 2 squared is 4, ln 2, can't really simplify that, so that's just 4 ln 2. And then the bottom, it might seem kind of tricky at first because you realize that the limit as x goes to 0 plus of ln x is negative infinity. However, I can tell you that after using L'Hopital's rule, it's actually 0. If you want to do that yourself, you can try it. So equals 0. And then e to the u du, because we know that actually this whole thing is equal to that whole thing. So we just evaluate e to the u 0 ln 2, and then that is equal to ln of 16 by just moving the 4 inside, and you know that 2 to the 4 is 16. So we actually get e to the ln 16 minus e to the 0. And those two cancel, so that's 16, and then anything to the power of 0 is 1, so that's just 1. To 15, which means the final answer is just 15.